Hey guys, so in this video we're going to be doing some more financial maths. This question comes from a matric paper. So let's get into it. Patrick decides to start saving before retirement. He makes payments of 10,000 Rand monthly into an account yielding an interest rate of 7.72% per annum, and it's compounded monthly. The starting date of the account, the starting date of the period is the 30th of November 2016, and the final payment is made on the 30th of April 2026. So the question is, calculate how much will be in the savings account immediately after the last deposit was made. Okay, so firstly I would like for us to just revisit what we know about future value and present value. So generally the future value is given by the present value, which is compounded at a specific interest rate over a specific time period, over a specific time period. The present value is given by the future value divided by the interest rate over a specific time period, compounded over a specific time period. So these two equations we generally use for what's called lump sum payments. So when we do a lump sum payment, we start with one payment and then we don't touch the account again until the end of the period. However, we see here that Patrick makes 10,000 or deposits of 10,000 Rand monthly for the time period. So we need to use a different formula. That formula looks as follows. The future value equals to the payments multiplied by 1 plus the interest rate over a specific period minus 1 over the interest rate and the number of times it's compounded per period. The present value is given by the payment 1 minus 1 plus I over n minus nt over I over n. These are formulas that you should be given, or you should know them, and these are for annuity calculations. So when we're dealing with the future value, it's when investments are made into an account, and when we are dealing with the present value, this is trying to find out how much money we can withdraw from the account, or what is left in the account after we withdrew a certain amount of money monthly over a certain period of time. But for this question, we are going to be focusing on this part. This is the equation that we're going to use here. Okay, so let's go. We said that the future value, which is what they are looking for, equals to the payments multiplied by 1 plus the interest rate nt minus 1 over I over nt. Oh, n, sorry. Okay, so let's start putting in the values that we know. We know that P is 10,000 Rand. I equals to R over 100, which equals to 7.72 over 100. That gives us 0.072. Oops, 0.0772. And then n is the number of times that it gets compounded per year. So in this case it is 12. And then there's something that we see here, nt. What is this nt that we're referring to? So it's the number of times it gets compounded, which is 12, and then we need to multiply it by this t. So the t is the time frame from the 30th of November 2016 to the 30th of April 2026. Now this calculation might come across as simple, but sometimes even I struggle to calculate dates. But I found a way to simplify it for myself. So we want to know what is, and by the way, t needs to be in years. So t must be in years. 2016 to the 30th of April 2026. So what I generally do is, if the end month is before the start month, like April comes before November in this case, what I do is I calculate from the 30th of November 2016 to the 30th of November 2025, a year before the actual date that I'm interested in. And that is 9 years. And now we need to count the months. So it's December, January, February, March, and April. So this is 1, 2, 3, 4, 5. We count 6 months, and this is 6 months inclusive of the first and the last payment. So if we're going to look at how much time has passed, we'll see that it equals to 9 years and 6 months. But this value can't be in months, it must only be in years. So we need to convert the months to years, and that gives us 9.5 years. We now have all the information that is required to solve this equation, so let's do it. Let's just write down the equation again. If V equals to P 1 plus I over N times NT minus 1 over I over N. Okay. So if we start plugging in the values, we get 10,000 there. 1 plus I 0.072, N is 12, 12 times 9.5 minus 1, all of this over 0.077. Oopsie, I made a mistake here. This should be 0.772 over 12. Okay, and if we put this into our calculator, we find that there is 1,600,000, let me just write this closer, 1,674,501 and 44 cents. And that is our answer. That is what's left in the account after the final payment has been made. So what are the important things to note here? Firstly, the important thing to note is that we're dealing with an annuity equation, because they mention that there's monthly payments and it's not a lump sum. It's not a lump sum, it's monthly payments that are being made. The next challenge is calculating the date, or the time that has passed between the two dates. Sometimes it's simpler when it starts on the same month, or it ends on the same month that it starts. Then your years are a nice round number. Otherwise, you have to calculate the months as well and convert that to a decimal so that you can have the spot year. Yeah, other than that, that's it. Thank you very much for watching. Cheers.